Hi everyone, and today we're looking at factorizing by grouping in pairs. So with an expression can be written using four terms such as x squared plus 2x minus 2, it might be possible to factorize it into a product of two binomial terms such as x minus 1 and x plus 2, which is what you were working with when you were looking at the distributive law and FOIL. So in such situations, the method of grouping in pairs is often used. And when we talk about grouping in pairs, you have to find pairs of terms that can then be factorized. So we'll factorize pair 1 and then factorize pair 2. And that can help us create our binomial product or our binomial terms. Remember, binomial meaning 2 compared to trinomial meaning 3. So factorizing by grouping in pairs is a method often used to factorize a four-term expression. Four terms, 1, 2, 3, 4. Terms are grouped into pairs and then factorized separately, as I just explained, and the common binomial factor is taken out to complete the factorization. So if we have a look at an example in red, we'll go x squared plus 3x minus 2x minus 6. We're able to look at, split it down the middle. That is one group of pairs, and that is the other group of pairs. So the factors of x squared and 3x are going to be x. X times x gives you x squared, and x times 3 gives you 3x. The factors, highest common factor of negative 2x and negative 6 is going to be negative 2. It's going to write minus 2, because that's the highest common factor of that pairing. Negative 2 times x give you negative 2x, and negative 2 times positive 3 will give you negative 6. And then what we're looking for is, are these two binomials the same? If they are the same, then we take it out. That's the common binomial factor. So we take it out. We only write it down once, x plus 3. And then we grab what's left over, what's not in the brackets. We have an x and we have a minus 2. And we group that as our second binomial in the brackets. And there's our factorization of the four terms using the method of grouping in pairs. In example 2, we have x squared plus 3x minus 5x minus 15. So same method again, we're going to split it down there. Grouping of pair 1, and then pair number 2. Highest common factor of x squared and 3x is just going to be x, and the highest common factor of negative 5x and negative 15 is negative 5. So on our next line of working, we have x outside of x plus 3 minus 5 outside of x plus 3. Do our two sets of brackets match? Yes, they do. So we have x plus 3, and then we grab what's not in the brackets, x minus 5. Now in example 3, we have it's looking slightly different. So the difference here is we have our power, we have our coefficient and our pronumeral with the power out the front still. This is non-monic, so we've got a value greater than 1 out the front, which can make the factorization process a little bit more difficult. And what you're looking for is, in your pairs, are you able to factorize that simply? Well, there's no common factor besides 1 between 2x squared and negative 9. And we should know from all of our experience in algebra that our constant term, in this case it's negative 9, should actually go to the back of the queue. And we should have our coefficients and our pronumerals in the middle of our term, with our terms with powers at the front of our expression. So we're going to rearrange this. So the common terms between 2x squared and the rest of the terms is just going to be x, because then I'm able to factorize negative 9 and negative 18x quite easily. So my next line of working, I'm just going to rearrange it. So we have 2x squared plus x minus 18x minus 9. And now that's in a form where I'm able to easily factorize it. So the common factor between 2x squared and x is just going to be x. Common factor between negative 18x and negative 9 is going to be negative 9. So on our next line of working, we have x outside of 2x plus 1 minus 9 outside of 2x plus 1. Negative 9 times 2x will give you negative 18x. Negative 9 times positive 1 will give you negative 9 still. Our two sets of brackets match. So we have 2x plus 1 and then x minus 9.